There you go. Sorry, man.
Cool. Oh no, you're good. Thank you for the reminder, Dennis. So yeah, so basically what I'm going to do today is I'm going to do the thing where I'm just going to say, hey, I think this is a good idea to use this for that. And then I've got two more presentations after this lined up where I'm going to actually try to like kind of build up more formally from within the math um to frameworks. I actually think we'll touch on a lot of the stuff you two, Gabriel and Dennis, were just talking about. Um, some of the motivations here are one, just in general, I've been getting more and more into the math side of all this. And so kind of wanting to show some of the things that I've been researching. Um, but also trying to come up with gateway problems for mathematicians where we come up with nice little mathematical problems that will entice mathematicians on purely mathematical grounds to get into our way of looking at things. Because I think a lot of times what happens is when you see big changes in sciences, you also see changes in the kind of like collection of working problems that mathematicians are kind of motivated by at any time, right? So like there was a bunch of stuff that came out of early calculus that became the stuff that a lot of mathematicians were dealing with relativity, with quantum. There were whole new frameworks for math that suddenly became the thing that and whole new problems that a bunch of different mathematicians came up with all kinds of different approaches to. I think one of the things we can offer as a group is just that, to offer collections of problems that present the formalisms in new ways that in and of itself will entice mathematicians because they simply haven't had a framework to kind of think about it. A lot of the mathematics that we're inheriting in the form of topos theory and linear logic and other things come from areas kind of outside of what we're talking about, like social reproduction theory. Um, Topos theory, especially the brand we're kind of dealing with, comes out of wanting to like have an axiomatics for quantum physics, or an axiomatics for like crazy weird geometries. The linear logic I'm going to talk about comes out of computer science and wanting to model computations. But in both cases, we have mathematics that have gone way beyond their original kind of scientific domain that motivated them, and in turn, kind of have offered us, and like especially like topos theory, and in my instance, like linear logic as well, and I think other people in different forms, there have been different logics and whatnot that have motivated us to kind of reframe how we think about social science. But we've been on kind of, I guess you could say, like a receptive and therefore I would say kind of amateur, modest position, right? Like where we're like very aware we're not good at this stuff. And we're very aware we have to kind of catch up to even know what we're talking about. But I think where we're getting to is a place where we have enough of a theoretical framework to turn around and actually kind of say, okay, these are good, sound scientific claims we want to make using these formalisms. How do we refine that? How do we kind of like drill into that and make it even more precise, So for example, with relativity, you have the question of once you like take three-dimensional space with a bunch of straight axes and add time as a fourth dimension and curve the whole thing, a bunch of what traditionally worked in calculus broke, right? It just like didn't work anymore. So for decades, mathematicians were motivated by how do we adapt calculus to work in this new kind of space that was not at all the space of Newton. That problem came out of having to address like this cosmological information that did not fit into the Newtonian framework. I think that there are similar things we can offer that we're dealing with when we're talking about the developments of things like social space-time, these complicated like modal logics that use all, for example, of like open sets, closed sets, and Boolean logics, which like I talked about last time are kind of like from a traditional perspective in math, they're not all that interestingly different, but kind of from our perspective have like a ton of useful different information, which opens up, I think, questions for mathematicians in turn, like, okay, how do we really flesh out those differences? What does that mean? So I think a lot of what we can do, and some of like if you go to the in the Discord chat, if you go to the Logic Task Force channel, Dennis has actually started a number of threads that have started to formulate questions from our perspective in classical mathematics terms. So like this is part of a larger kind of project of trying to uh like create little booby traps for mathematicians where they get super interested in a math problem and then like we pull them into the whole theory problem. So in that spirit, one of the open questions today is the relationship precisely between topos theory and linear logic. And there's some kind of broad stroke stuff that over the next couple presentations, not today, but over the next two, I'm going to start talking about how those interconnect. But that's a very active research question within mathematics today. So that's the kind of question amongst others that we can turn over to mathematicians, assuming that like I make a compelling case for what I'm trying to do with linear logic here. So also down the road, I want to present on another model of linear logic, which I won't get into anytime soon, dialectic categories, which De Paiva developed, who we're have connections to and are talking to. So there's like, I guess like strategic objectives in this that aren't necessarily tied to any particular formalism, but are part of an overall strategy of trying to find ways to more productively, I think, relate to the world of formalisms where we're offering, I think, kind of intuitive problems and motivating problems to look at these things. So that's kind of a high level perspective on this. And so just to jump into the formalism, linear logic, the basic idea or the postulate I'm going to go with is that insofar as we're now talking in the language of systems and environments coming out of Gabriel's presentations, which has had a pretty immediate, I think, compelling, both kind of synthesizing function in terms of tying a bunch of our theory together and explanatory function and kind of, I think, making sense of things that earlier we used other concepts for that didn't fit as well. I would like to propose that linear logic gives us the logic of the interface that emerges between any given system and its particular environment. It gives us the generic form of that interface, which can then be further specified for a particular system in a particular environment. This comes out of an idea that's been a big part of why linear logic has been the subject of a lot of mathematical research, which is that it is a model for the basic kind of language of computations typed lambda calculus. In other words, the language of kind of like input output. And what we're talking about in terms of systems is this kind of like interactive back and forth between it and its environment, which can be ultimately expressed as like a series of input and output relationships. So we can kind of look at the typed lambda calculus as a place where that is modeled, but I'm going to set that aside because this thing called the Curry-Haskell isomorphism basically lets us say that we can talk about what we can do with those things that model input-output with linear logic. So what that means is what linear logic lets us do is keep track of the way that we transform information between different environments and between different systems, specifically with regards to the costs of that information process. Linear logic came out in large part from the study of actual like algorithms and actual like computational processes, which take actual data and actual time, which ends up for like in terms of social reproduction costing energy and other things, but in terms of like the math, it takes space and it takes time. It's not just like an infinite resource that can be tapped into. And so linear logic started from the question, what if we don't allow just infinitely adding or taking away different logical statements, but you have to essentially pay for each bit of logical information that you use in order to kind of infer a better picture of the whatever it is you're mapping. In this case, let's say an environment. So the idea here is that we want something that will give us a way to talk about any particular system in any particular environment, which on the one hand will give us a kind of generic picture of what it means to kind of have a system of interactions that have costs that are related to material substrates, and that also have the kind of points of ambiguity that were coming up just now. So in other words, we're not everything is fully fixed and broken down into pieces. So this comes out of MES, memory evolutive systems. It's called the multiplicity principle. So if we take something complex and break it up into its different pieces, we can't explain what's happening just by its pieces. Something emerges out of the way you fit these things together. So what we're interested now is like, if we're a system in an environment, how are we going to be interacting with other systems and components of the environment such that we're building things like the co-limits of MES, or we're participating in things like the games that were used to model some aspects of exchange logic and stuff back in the days of the primer, which are already a bit ago. So one of the motivations for linear logic is it gives us a way to think about how a system senses as an organization its environment with the costs. So we could think about this in terms of social reproduction of that information. And this is important here. And I guess I'll share screen. Why not? Let's go ahead and just start that. Yeah, we'll start there. What we're trying to do is we're on the one hand trying to have a basic language to talk about how organizations as systems sense their environment. On the other hand, we want something that will let us recover the topological semantics that has become the kind of main model for our theory of the social modes. So just to go over that again real quick, we have an idea of exchange relationships being modeled by things that don't have a strict boundary, but get kind of like infinitely close to each other. We have the idea of gift exchange being modeled by things that share a boundary and so can be contradictory back and forth. And then we have the model of property relations or property exchange, where something definitively passes in or out of some kind of relationship of ownership or participation. So we have like three different ways of thinking about not just these exchange relationships, but the actual kind of geometry of the way they take up space, the way they form boundaries, the way they differentiate themselves from other components of the larger environment, and how they kind of like coexist at those boundaries, whether or not those boundaries are shared, like in mode A, whether or not there is no strict boundary, like mode C, or whether or not just one side or the other has a boundary, like mode B. Linear logic has the ability to recover each one of those kind of three states by adding infinity into its rules. So
Man, what's written on top there? I can't read it without zooming in.
yeah, no, I'm sorry. I was gonna get this contrasted, but I didn't. I ran out of time. Let me just zoom in. Okay. So those rules right here, if you take a look at it, one is you start with something and you add something else. So you get something for free. Here you have something and then you take something away. So you're taking away something for free. So these are both permissible rules in classic, good old fashioned like set theory and propositional logic. These are how you can kind of get infinite premises to do things with when you need to like prove something and you need to use the same axiom over and over again. You can copy it infinitely. Or if you just want to introduce something in order to make something happen and then get rid of it, you can just kind of freely toss it out without any consequence. What linear logic says is no, you can't do that as a basic starting point. Everything you do has a cost. That cost is ultimately determined in different ways, and I'll come to that in a second. But the main thing I want to drive home as a starting place as to why this is useful for us is that these two operations here, which have the same kind of like logic as like modes, or sorry, as modalities, are what enable the linear logic to recover intuitionist logic, which is this side, or paraconsistent logic, which is this side. And it does so in a really weird way, which is this is the kind of base logic structure that linear logic uses, which is called a sequent. And it has a number of statements on this side that are the premises, and a number of statements on this side, which are the consequences. And what linear logic showed was that if you allow on just one side infinitely adding or infinitely taking away information, you can recover one of the two kinds of like topologies. If in your premises you can infinitely add or infinitely take away information, you're capable of getting an intuitionist logic or paracomplete. If in your consequences you can infinitely add or infinitely take away logic or pieces of information, you can recover a paraconsistent, or what we call mode A. And then if you add both of them, you can actually get classical logic altogether. So you
Can you
start from
repeat
these.
that? If you allow infinite, if you have infinite resources on the side of premises,
Mhm.
the difference is whether the infinite resources on the side of premises or consequence. Is that
Yeah,
it?
exactly. Yeah.
So
On the side of premises are intuitionist, so what we're calling mode C. And on the side of consequences would be paraconsistent, or what we're calling mode A. And so there's this really interesting sidedness and something that comes up here around the process of entailment, that what we're modeling in terms of topological semantics has this side in terms of kind of information probing, that on the one hand we can either, in terms of what we are supposing, we can infinitely like manipulate that. I think there's like some intuitive ways. One thing that comes to mind is like the process of like bidding and all the kind of like subtle adjustments there. But I think there's a lot of like work in like actually interpreting what this would mean. If you then allow both sides to infinitely add or take away information, you recover like a full Boolean logic. These rules, which are called contraction or weakening, are called structural rules. So as opposed to what we're used to in terms of like conjunctions, disjunctions, negations, implications, which are logical rules, these are kind of like the overall permissible way information can be used. And in linear logic, the only structural rule that's allowed is called the exchange rule, which means you can kind of like, if you have A x B, you can make B x A without that costing anything. If you take that away, the logician Lambic showed that that's actually the basis for a natural language, for a sentence structure. If it costs something to even manipulate the way the ordering of words and whatnot, and we can think about this in terms of like it's the order, like in most languages, the order, even like if it's just connotation, the order of words has like a different meaning and will cost you more or less effort to express that meaning depending on how you order the words, right? So what you have here is if you start with linear logic as a model for the interface between a system and an environment, not only can you then like recover the three topological semantics, but you also have a way to ask this question of like, what is it that like these weird entities, human and those entities tending towards like more or less like cognitively like self-reflexive, like what is it that enables something like natural language? Is this subtraction of even like an exchangeable this like the fact that like again like just the ordering of things, you can reorder it without a cost. So there's different ways to kind of look at how those costs play out that let us recover our social semantics and our overall language and give us an idea to formalize something that we've been talking about in terms of language, which is that its apparent kind of flexibility and capacity to talk and cover everything is actually in terms of logic precisely its weakness, right? The fact that every kind of move in language costs something is precisely why like you can do whatever you want with it, but then it becomes actually incredibly expensive to constantly have to like re-articulate in another situation what it is you were trying to say in the first place. The more structure you add to a logic, the more you're capable of kind of like specifying the details of a situation. Yeah.
John, can I ask a question just to clarify?
Yeah,
Uh,
totally. This would be a good
I
opportunity for that because I know I'm
yeah,
just kind of jumping around.
no, I mean, I don't not even gonna go into the just the craziness that you can distinguish these logical systems based on infinite, like costless adding of premises, of costless adding of, I mean, that's crazy. But my question is a bit before that, like, what does Girard and our friends, our linear logicians, mean by cost?
Mhm.
Because it's not costing this, it's not directly like, or computation takes time, right? That's
Mhm.
one of the things you can model using this, if I'm not mistaken. There is like a more intrinsic meaning of cost that has to do with how many times you can use something. You spend the usage of something, you cannot retrieve it, right?
Yeah, exactly. Like you can kind of derive the space-time costs from the logic. But yeah, no, you're right. The idea here that I think is useful, especially for trying to think through what an environment is for any particular system, is the idea, and actually I'll jump over to the other picture. This one. There we go. This is one of the semantics, one of the main semantics. And also let me get, ooh, yeah, let me get that picture. Sorry. Just one second. Go to another one. All right, so this is something I've only just started to recently wrap my head around. And it comes out of quantum physics, but it's not that crazy, even though it comes from that. Which is this symbol here, which is a symbol for orthogonal, which is a higher order notion of perpendicular. So, if we've got like our X and Y graph, perpendicular just means that you can move along one axis without having to move in another axis, right? You can just move along X or just move along Y. I just did that wrong, but you get the idea. Orthogonals is a broader notion of that. So essentially means you can do something without affecting other things around it. So when you're modeling computation, for example, you're really interested in what's called side effects. Like you want to know whenever you run a particular computation, all the things that are going to be left behind by that computation.
Dude, what's that symbol there? Here.
This
No,
what?
is there what's its relation to P? Is it
Oh, okay.
smaller
So
or
yeah,
greater?
P is just this commutative monoid. So like a commutative monoid is think like the integers adding and subtracting, right? Like you can go up and you can go down. So the basic idea of phase semantics is
Yeah, but
this right here.
Okay.
Oh,
Yeah, just this symbol here I highlighted, like.
oh, sorry, it's subset.
Okay.
So this orthogonal is a subset of these, which I'll explain from here. The basic idea is like if you're trying to verify any particular piece of information, there are going to be phases, like steps you're taking between not knowing anything and having verified that fact. These orthogonals here, this subset, are all the phases that aren't affected by any particular step. So what that means is like if you're trying to figure out something about how to like get a food source, everything that is not affected by that like line of inquiry is going to be orthogonal to that inquiry. For any phases going from not knowing anything to knowing what a fact is for 100%, there are going to be phases that take you into irrelevant information, things that do not have anything to do. And what that here symbolizes essentially steps or paths that take you to outside of the relevance of your like information. A fact is what happens when you have like doubly gone through that process. It's involutive essentially, and this is like I'm still personally trying to fully understand this because that should be a bracket right there. I'm still trying to get this myself, but this has to do with problems from quantum physics where it's not always the case that you can affect a particle without affecting everything around it. So sometimes things are orthogonal, that is, you can affect things without affecting other things, and sometimes they're not. So in a sense, what you're trying to do whenever you're trying to verify if a fact is the case is to determine everything that is not relevant to it, and then everything that is relevant that is not relevant to what is not relevant to it. If like I wanted to have Raziak stuff up, but I will have to come back to that another time. But this is very similar to the process whereby like we figure out information with the topological semantics, right? Something is a fact if all the information we have about that fact is precisely filling up what is relevant to that fact. So we've cut everything else that is irrelevant and then cut everything else out of that. Sorry, I'm not describing that well, but you can kind of see like that these facts like have a logic of like something that is relevant to the information that you're trying to like figure out. Again, like I'm trying to figure out how to feed myself. And then once you figure out where the food is, that's what a 1 signifies. Right? So basically the idea of phases is that these are the ways that you first and foremost even draw a picture, a fact in the first place that is relevant to your situation. And then you ask the question of verifying that fact of whether or not it's even true. So this is kind of a 2-step process. One of getting pictures that are relevant, and 2, determining whether or not those pictures are actually accurate. So these are the four basic, and if you include this one, five basic operations that would kind of give us, before we talk about those modalities and the infinite adding, right? So this is where everything has a cost right now. Nothing does not have a cost. So we can kind of see in terms of set theory what this looks like. We can take the intersections of things that we've established as facts. We can connect facts, but we have to do the same process again where we kind of fit them so that they're precisely at the border of like what is relevant and what is not. We can also like link facts together in ways that this would be like closer to actually like limits and co-limits here. But we can actually kind of combine facts in a way that let us like open up larger spaces of information. So this would be like, for example, here we might have a fact that gets us, okay, I've gotten from my home to a water source, and I know that generally like game is around that water source. And then from here, we've gone from that water source to adding information to a particular like place where an animal is living. So we're kind of adding pieces sequentially of the information. But here, for example, we might take the fact that like where we know where the water source is, and we take the fact that we know where there's like plains nearby with a lot of grass. So we're actually combining different information and looking at what we can tell about the overall map from that. And one of the ways these are modeled elsewhere in terms of like game semantics is additives give us sequential moves and multiplicatives give us parallel moves. And so these are different ways of kind of like making choices. There's more in the book I can go to in a second. But I think this is like a good starting place to think through like what this looks like, that we have kind of zero states of information, and then we're able to determine when we have a particular question what is not relevant to those questions. We then have kind of like this top, which signifies like all the useful information we have. But this one here actually kind of signifies getting to verify any particular fact. And then finally, we have like these bits of information that we know are facts, but like, you know, we haven't been able to actually connect them to any verification process, nor have we been able to fully rule them out as being irrelevant to that process.
So I have a question here.
Yeah, go ahead.
Is it possible for a fact to be verified but not true? Or the other way around, is it possible for a fact to be true but not verified? If T is true. I don't know if T is considered true here. Global.
Yeah, that's where here, let me try to pull up the exact space. So yeah, we're starting with just like where did the fact definition? Okay, there it is. So yeah, so we start with like the verification is like I think the truth in like a correspondence sense, like it maps on to something, whereas like this would be more like something closer to like validity, like not quite, but it's something that meets this condition of having kind of like been fitted precisely to whatever the information question is in the first place. And so like one of the things Jar talks about is like if we're talking about things in terms of input output operations, this orthogonal can also be conceived of as like the opposite of that. So we conceive of like, there we go. We can conceive of like G as an input, like a probing by a system into the environment. The G orthogonal is everything that is outputted from the environment back to the system along that particular line of informational inquiry. So if we're not asking the question from more like a knowledge verification, but more like just like a more or less meaningful statement, I think would be a way to put it. Something that's a fact, sorry. Something that's a fact is something that when you've like set like probed an interaction into the environment and then gotten information back from the environment, it is precisely the actual like information that you're like trying to get. Whether or not that information is correct is, yeah, this part. But I think that here it's like a question of like, are you even asking like the right question in the first place? And are you getting back like even a relevant statement in the first place?
Right. That's really interesting. I wonder if we could say that P consists of all observations of a system. And then a subset of that is G. So we take a set of observations out of the total set of possible observations. And that set of observations becomes a fact if the orthogonal, if you apply orthogonal twice, which like you're saying, it's like a fitting function. It's like saying that this set of observations is minimal or maximal with respect to some yeah, like you said, some fitness. Right? Because it means like you don't need any more observations to explain this thing, and you can't do with any less observations as well. Like it's the exact amount of observational stuff you need.
Yeah, and I think there's like also like a layering, like it's like we're looking at exactly the space of observables that provide precisely the amount of observations we need. Like there's like almost like a passive and an active or something like that. From the interpretations. I mean, one of the other things that's crazy about linear logic is like there's so many models and so many interpretations. It's proven to be really useful. Like for the programming nerds, like Rust is based on linear logic. But even like Girard says, doesn't always know how to actually interpret some of the operations. So yeah, so I think that's like if we think about it in terms of observations, I think that makes sense. And then we can think about like each of these statements, and especially each of these like operations that combine these different bits of information. Those here are what give us an idea of like what cost looks like. So we actually have to like have these statements somehow. We have to have gotten them somehow to actually add them together. Now this again is something I'm still not quite sure how to interpret, but I think it's going to be super useful. Which is essentially, there we go. So when Girard builds on what I just showed you for, here's the thinning. So you can add on the right, you can do these different things. And he doesn't make all the possible combinations because he was making some choices based on what he wanted to do. There are more exhaustive lists elsewhere. But where's that picture? There we go. This I think is where like where we want to get to in terms of like what this gives us. this idea of the
Can you go back to the picture just before you move to the next thing? Thanks.
So when we're trying to look at these two things, this exclamation mark, which allows you to add or take away on the left, or this question marks, which allows you to add or take away on the right. The right side, well, actually, let me make sure I'm not fucking this up. Bum, bum. There we go. We now have this idea of facts, which themselves are closed or open. And they're closed or open based upon what kind of information state we're now allowing to infinitely add. So where did that go? Okay. So if we take all the facts, there's this subset of facts, right? So we've already know the facts are what we just talked about have been fitted so that we have the kind of correct space of observations. Now within that, there's a subset of facts that have the essentially the characteristics of a closed topology. You can take infinite intersections, you can take finite, the equivalent of joins here. There is an intersection of the whole space, which is precisely all the orthogonal phases. And it's idempotent, which means like once you apply it, you've gotten everything you need out of it. There's no point applying it again. Though that plays a big role because that's also where you get a lot of the redundancy that we use for making copies and stuff. But essentially what that means is if the phases, if something is a fact and it belongs to this space, then it is a closed fact. And if it is a fact and it's like orthogonal belongs to the space, it's an open fact. So it doesn't make it not a fact. What it does is it changes its status in terms of like where it is in the process of exploring the overall space of information. So we now have this like mapping, which is not just like pure roots or paths like we did initially, but like what the modalities actually enable us to do, like in terms of the geometry, is actually start to think about like a space within which we are exploring and kind of looking at these facts. Again, I'm still trying to figure out how to interpret that in terms of our theory, as well as just how to make sense of all this. But this is where like a lot of the power of the system really comes in, because by allowing these different kinds of like kind of topological fact spaces, Girard built a system that could then recover whenever it wants to kind of intuitionistic power or paraconsistent power or Boolean logical power. That has consequences in different areas depending on like, you know, what it is you're trying to do. Essentially in the world of computation, that comes down to actually reading and writing information, putting it down, copying it, deleting it. So it corresponds to the actual like process of inscribing the data somewhere. So I think that this gives us an interesting way to start thinking about like what exactly it is that exchange relations, which even have the word for the one thing that like linear logic does keep, right? Like exchange relations kind of give us places. Sorry, kind of lost my train of thought there for a second. Well, I had it going somewhere clearly, but I just kind of lost it. But like, I think that this is useful because what it lets us do is it starts to give us a way that we can treat the different social modes as different attempts to solve the problem of collecting information. With computer systems, it's a matter of like how it stores data. With the social modes, it's more a matter of like how exchange relationships kind of like exchange social information, whatever that means. So I think that that's a good like pause point. There's more I want to talk about, but I think that that's like another good place. See if there are clarifying questions or thoughts about how to adapt this or whatnot.
Yeah, I think, I mean, this is a lot. I have to think about it. I'm not sure I understand I'm not sure if I know how to interpret what this closed facts F set is, because it is like a topology, but they define it as a topolinear space, right? But I guess a topolinear space is the whole thing insofar as it also includes F, the set of closed facts, right? Topolinear space is not F itself. It's the quintuple that also includes F. I think it's on page 52.
So yeah, so it's, I think there's a few reasons. I think there's like weird technicalities about which symbols are being used that aren't the same.
No, but
also,
yeah, I can see there that this is very similar to the closed set topology, closed set algebra definition, and
yeah.
the orthogonal sounds a lot like this pseudo difference operator, those things. So, but just to understand first, the topolinear space is not this. This is F. That something that has that structure is F, and that's part of this quintuple, which also exceeds it, right? The fact space of fact of P is larger, and F is a part of it. So you're adding structure to that, and then you're calling it, it's not the phase space, the topolinear space, because it also includes F. And it sounds like when you add that structure to the space of facts about P, you get all these different additional structure for it, because now you can distinguish if your verification G of a fact in P, if it will fall inside of F or not, or if it's orthogonal falls inside of F. And with that, you start differentiating. So you added more structure to that discussion to that kind of picture of facts, right? What is not clear for me is like, if there is a path G for verifying a fact in P, and it belongs to F, or it doesn't belong to F, or it's dual, orthogonal dual belongs to F or not. Like, what are we distinguishing exactly? Like, what is made different because of that? Like, I was following mildly, kind of barely, while we were talking about this basic intuition that I'm getting the sense of it. Like, it always goes back to a kind of imbuing logic with a sense of economy, right? Economy of means. And then you get like, you know, differentiation of logics based on this economy of means. So you get like paraconsistency, paracomplete, classical, and whatnot, based on, is it cost-free? Is something about it cost-free or not? And then you get into linear logic, and okay, we're going to look at something where everything is costly. So proofs, you already get that nice idea where proofs and programs are being brought together because programs are clearly costly. Now let's make that about proofs. Proofs are costly. And then paths on an observational space towards verification, that's a proof, right? But pretty much like he's using the Girard crazy language because he needs to change everything because he's French to talk about a proof that verifies a certain fact, right? Is that a correct direction to take, or is this simplifying too much?
No, I think that's, yeah, definitely.
And then he's saying, okay, but I want to be able to tell apart this kind of economies of proofs, Like, are you using irrelevant information? Are you reducing to just the relevant information? And can we apply a certain criteria of relevance and irrelevance where you get the duality of relevance and irrelevance, right? So the irrelevance of irrelevance gives you back relevance, which is the evolution that you were talking about with G.
Mhm.
The irrelevance of the orthogonal of the orthogonal is G itself, right? So he's trying to extract information about the economy of means of a proof based on these kind of operations between irrelevance and relevance, it sounds to me. I can kind of, in my very weird way, follow up to that point, which is already a really kind of counterintuitive but very intuitive idea. But then I don't, when we get to this point here, I'm not sure I follow. Like, what is then a closed? First, I don't think I follow. Like, what is the family of facts that satisfies the conditions of a closed set topology? Like, what does that tell us? Like, what did we learn from that? Like, I don't have any intuition of that. Like, I know that he then uses this to define affirmation, consideration, and so on, right? So he comes up with cool operators that are more intuitive or more clearly operational in logic by mobilizing F. But what is F actually naming? Because in the crazy drawing you showed us, you get this idea of closed facts, but those are not the facts verified in P. Those are facts under a certain condition, right? And it seems to me that the condition of closed facts, which is, it kind of connects with this idea of a closed topology, it has something to do with where irrelevance comes, where orthogonality will be, the third condition, right? On page 52, when he's giving just the conditions he needs to satisfy, there's the idempotent condition, which I don't understand, but the third one about the how do you say this? That there is the meat of the whole space equals
the intersection of F is the I think that he calls that the absurd, P absurd or something like that, or the orthogonal space of P.
Yeah, because that seems to be, whatever that means, seems to be what defines it as a relevant operation, right? The idea that it's not that the union of everything gives you the true, but the intersection of everything gives you the absurd, right? So why would you want that? I think you want that in the space of facts, where facts are neatly distinguished and they don't include any information that is relevant to another fact. That's kind of an intuitive idea of why every proof is a closed subset, because like they include their own limits. Like they contain everything that they use is part of what they are, right? I'm trying to find like a reason why this is a relevant structure to define, so I can understand what he writes afterwards. Like, why would you want to define this closed space of facts, or a closed subspace of facts, right? Because it's not even it sounds to me that being able to say, well, if you take the intersection of all these facts, you get just pure irrelevance, pure absurdity. That follows from I'm not sure. I just wanted to understand it a bit better. I'm not sure if you have any.
One thing that might help, at least I'm from reading the text and listening to John, is we can think of, originally I was thinking we should think of it in terms of observations and then grouping the observations together to form facts. But actually, now that I'm reading it again, I think it's supposed to be, or another way to think of it is as work that you need to do to verify a fact, right? So things that are verified, they contain the singleton. That means it's no more work needs to be done. They can be
Yeah,
they
I think
can now
that's
be created. That proposition can now be kind of produced by the system. But other facts, you need to do some work to reach them, right? And so then that gives another interpretation of the dual function, which is if you take the dual or the orthogonal of a set of work, you would get work that's unrelated to this work. And if you take the dual, that unrelated work, again, you would ideally get back to the original, meaning this is the maybe most efficient or the right amount of work it took to verify this fact. So applying this orthogonal operator twice means if it gets you back to where you started, then you have done the right amount of work.
Yeah, now that you said this clarifies why you want a space of closed facts, because isn't the space of closed facts a space that is only made up of workable information? Meaning, if you take a part of F, you should be taking only things that are meaningful to prove facts in F. You're not taking any useless work. But the complement within F is also useful information. It's not useless. So if that's the case, you don't get, it's paraconsistent in that sense, right? Because if F is a family of facts inside of the facts of P that are, let's say, the most economic part of it, it's the most dense, workable part of the fact space, then the complements of a workable proof are not all the irrelevant observations or irrelevant work you're doing. It's relevant as well, right? So you cannot take the complement of a efficient proof to be in a useless knowledge, right? Or useless steps, perhaps. Does that make any sense? I'm not sure.
Yeah, and I think like when we're looking at this guy, it's everything in the total P that takes H to irrelevance. So you're looking at the entire phase space when you're doing that. So I think it's like the irrelevant is always kind of tending towards the larger, or like you're trying to like kind of constrain that down to a certain extent. I'll be right back. I gotta use the restroom real quick.
Sure.
But Gabriel, could you say what you were?
Yeah, I'm just trying to find any sense in which I can recover whatever I know about closed subsets, closed algebras, and paraconsistency, and relate to this. Like, what is the relevant or meaningful idea regarding? I mean, because I think you just said exactly what I was trying to say before. It's not so much about observations, but about, right? I mean, you call the path of verifying a fact, you call it a proof, but it's a concept of work sensitive proofs, right? Which is very similar to the idea of programs, right?
Yeah, exactly.
So
like you click, if you thought about like a app on your computer, the 0 at the bottom is when you press start, and then it's running, and then if it terminates, then you have a fact. Something like that.
Yeah. So you have this idea of, tracking the work of proofs, which gives you a measure of the cost of a proof, right? And we're kind of calling, it seems to me, a fact, a proof that is the most economic proof. Now, how do you know it's not economic? Because it includes orthogonal observations or orthogonal steps, right? And I mean, a lot of reasoning goes like that. Like I'm trying to think about, you know, does a square have 4 sides? And I think I like squares. Squares are interesting. I saw a square once. You know, there were 4 people, 1 in each side. Therefore, it has 4 sides. Like 2 or 3 of those steps I could have removed, and I would get the same proof. I'd actually get the most efficient version of the proof because some stuff was irrelevant, right? You can even go further. Like there's a proof that doesn't require you to return to the idea of square every time. You can have like a proof that goes square, you know, square is a form, forms have sides and so on. And then you know, like you don't need to even go back to the ideas that you were using before. So there is a sense of like retrieving the meaning of logical cost that is associated with how much work and how many steps and how much material resources the proof takes, right? And it does seem to me that on one crucial thing that I'm seeing in what John is presenting is that one way of talking about like in the first part of the presentation, before the first question, the idea of cost was about adding or removing terms to a logical sentence, right? Now that doesn't seem to be exactly, it seems like a big broader idea. The orthogonal operator is, at least nothing has been said here about it ranging over the economy of the sentence, of a logical sentence. Is it filled with paraphernalia? Are you using redundant stuff? Are you cutting everything that you don't need, right? Or do you need infinite resources to say what you want to say and to think through a certain proof? It sounds like it's a matter of, is the information or the observation or whatever you want to call it that is being used as part of a proof, is it relevant or not, right? So it's a different notion of efficiency. It's less about resource and more about work, exactly as you said, right? Is it an efficient use of the resource, or is it using irrelevant stuff? So I kind of get to that point. And then it does seem like, well, the orthogonal operator is allowing you to move now in this proof space. There are purely efficient proofs, there are less efficient proofs, and then you can ask about the complement, like the dual more generally of a proof. You can ask about, well, the dual of a very relevant proof that only uses what's necessary. It's like purely unnecessary information, right? It's like a useless work in general, or perhaps if it's a proof that has some useless work in it, useless steps in it, something like this, right? So at that point, we get some way of partitioning the fact space. And it seems like it's at that point that the distinction between closed, open, clopen comes in. Are these partitions, you know, clear cut? Are the complement of these partitions of the same quality of the thing that you've partitioned or not? That's when you start getting closed, open, clopen stuff, right?
Mm-hmm.
But what I'm not clear is, what is a closed set of facts? Like, what is behaving that way, right?
Mm-hmm.
Does it make sense? I mean, I'm just trying to clarify my question, so not even clarifying what's written.
Yeah, you mean like the F itself? Like what is F here?
Yeah. That's why my idea, this is all to go back to what Dennis asked, like what did I mean? Like what I meant is perhaps an interpretation of F is you have all the facts of P and you have a subset of that space, F, where everything is effective, meaning there is no useless information. So if I try to partition F now, I will get in that region a paraconsistent topology, I think, because the complement of a work efficient proof will not be irrelevant information, orthogonal information. It will be also work efficient steps in a proof.
Mm-hmm.
If you have that space, it would behave like this, I think. But I'm not sure. That's what that's where I'm stuck.
Yeah, well, one clarifying point is, I don't think, well, for one thing is the P that we're talking about here, the thing at the very top. Well, actually, on the picture it shows T, right? But it's actually, this whole space is called P, right? And am I correct in saying P is a single proposition? So this is a space of possible ways you can get to.
I think P is the phase space.
It's the
P is not
phase
proposition.
space.
Yeah.
But what does the phase space represent? It's a space of.
Yeah, go back to that image. Go back to that image. Just 1 second. John, let us know if we're derailing things and can.
Oh no, this is great. Like I said, I didn't get as far as I wanted, so I like this. Plus, I think it's good to.
It's on page 55, the big drawing.
Oh, that one. Okay.
Yeah,
Gotcha.
both of them are fine if you want to go to the other one. Yeah, just go up. Just go up. Just 1 second. You have a Hasse diagram there that we can use. Yeah, so the phase space, this one also functions, right? This is the phase space, and it goes from
Like,
starting to halting,
Okay.
right?
So this is not a single proposition necessarily. It just, they all seem to converge with and halting at the end. Which I think is fine.
yeah, I think it's more it's any given kind of like set of informational tasks, like if we're going to put in work kind of language, like and so like, you know, if we were sending an email to every person on a list, right, like G and H would be each email being sent terminating in 1, and then I think once that list is complete, you'd hit top.
Okay.
And if you were filtering, for example, like, no one in marketing department, that would be your local bottom. Kind of like, oh no, this doesn't apply. So you'd start from 0 saying, like, oh, is this person in marketing? Yes. Oh, they're irrelevant. No. Then you go on with the computation. I think that's how it works.
Okay, yeah, the thing you said, Gabriel, okay, this makes sense. And the thing you said, Gabriel, about removing the unnecessary, right, and getting like the most efficient way to calculate a proof, it seems like that's just what a fact is. All facts are the most efficient way to get something, to get somewhere. Because the orthogonal operator gives us the waste of something, like the wasteful work. So if I have a set of tasks and I give it, I pass it to this orthogonal, then I get the set of tasks which would have no bearing on every task in my original set. So it's like what would be wasteful. But then if I apply that orthogonal again, I would get the waste of the waste, right? What is the waste of the waste, or the redundant of the redundant? It is the fact.
Mm-hmm.
So already every fact is efficient. But so when you were saying, because I thought you were saying like closed facts are more efficient than other facts, but I think all facts are efficient.
Yeah, no, I meant that closed facts would be like a lattice of efficient facts, such that what is useless for one fact, but what useful information of one fact is also useful for another fact. So you can't split. That's what I was thinking. Like, you wouldn't be able to split the closed facts topology in a way that you get a closed fact and an open one, right? Like, you wouldn't get like disjunct parts. So that's basically what I was thinking. Like, that if the intersection is redundancy, Meaning you can't just go to this thing here and split it like this, right? And say, this is G, and this is the redundancy of G. And then getting back to G by applying redundancy back. So if this is not true here, in this particular part here, what is the structure of this part, right?
Yeah, because you can get, by definition of open facts, you can get from any open fact into a closed fact by applying redundancy. So you can go into the closed fact. Yeah, that this page here. So G is open if and only if, wait, not this one, but the one on page 53.
Yeah, there you go.
Yeah, exactly. G belonging to facts of P is an open fact if and only if the orthogonal of G is in F, the closed. So if your orthogonal is closed, then U must be open. So we can use the orthogonal to go from open facts to closed facts, but it doesn't seem to suggest we can do the opposite.
No, but just go up a bit more to the definition. Yeah, so, but it also tells you something about the facts in F, right?
Yeah, like you mean the property number 3, which says if you take the intersection of every fact in your closed facts, then you get they're all orthogonal.
Yeah.
They have nothing to do with each other.
Yeah, so that doesn't seem to be a property that relates to, it's trying to tell us something about the relation between facts in F, right?
Yeah.
So that does seem to me something like you can't move from one fact in F, one, and you get another fact in F, and you're saying that there's something about the information, the steps here and the steps here, that if I try to get like now the intersection between them, I don't get anything. So it looks like they're like efficient on their own.
Yeah, exactly. It's like saying the set of facts in F as a whole, we can't really find any commonalities between them in terms of work. The work it would take to prove one fact in F cannot be reused in another fact of F, something like that.
Yes, that's what it sounds like. That's the type of kind of interpretation I'm trying to understand. What it is telling us about the lattice of facts within F, right? It feels like we're talking about a space that is more like this, like, and you get like every path is a separate path in comparison to something that is like this, where you get like this one step divides into two. This one also uses this, you know, like, so I can't really split this. If I take this as a fact, this path of a fact here, right? Well, this other fact here uses the same information as it does, right?
Whereas, yeah, that makes sense. That would make sense why we call it closed, right? Because the boundary, if it's being reused, then you can't say it has a closed boundary. It doesn't include all of its boundary points, right? Because part of it is included in the other fact. But yeah, okay.
Yeah, the reason sorry, Dennis, yeah, go ahead. Sorry.
Yeah, so if we can choose, if I have all these facts, if I can pick out some facts where none of the work is being shared, then it's a closed set of facts. But so this is making me think, is the fact itself closed, or is it the set of facts that is closed? it's okay, it's a single fact that is closed.
Yeah, but once you define, you
Yeah.
have first of an idea of a closed subspace of the phase space, which is F. And then based on that, you define closed and open facts, right? You need
Okay.
to know what F means first, right? So you have the question, does G belong to F or not here, right? So you already need to know what this is. So you have this as a closed space already. And then based on this, can you define if G is closed or open? So you need to be able to, you have the phase space. Then you define some space F. And now based on this definition, he's telling you if a fact G is closed or open, right?
Right. So G can be both also, right? It can be clopen as well. So you can be both open and closed if in some certain situation, but you can also just be closed by itself or open by itself. Okay, so G, so it's possible that G can exist in F, but it could also exist in O. Or one or the other, or both, right? Okay.
Yeah, I think it might be I think a lot of this elsewhere Girard talks about experiments. He does it in terms of his other semantics. But I think one way to look at this would be that like the intersection of F is the place where like the experiment consistently fails. And so that doesn't mean that you're not getting back measurements that fit like an effective kind of input output mechanism. So they still fit the definition of a fact. But that this right here is all of the kind of tasks that take I believe each and every element of P out of relevance. So the intersection of F is whatever in the kind of field of investigation that is always gonna kind of like return nothing relevant, but which still fits this kind of like this notion of fact. Another interesting thing to bear in mind is the verification of a fact. The one is a member of the fact. So the thing that indicates its completion is part of the overall statement. So it's not like the phases are like they're all like kind of linked together in this way. So I think that might be something else with the open and closed idea, is with the kind of ability to infinitely add or take away, that gives us the ability also to approximate. And so this goes from having to choose between one particular thing and another to being able to kind of like nudge in one direction or another. So that in the first diagram, we had just specific lines or paths, but in the second diagram, we had spaces, all of which places you kind of meander towards your goal, whatever that is.
And if you want to move forward so we don't stall you too much, we can go back to these questions afterwards as well.
No, this is good. Let me see what else I really wanted to touch on. I don't want to go into the coherence. We're just doing phase right now. That's more than enough. The next time I get into this, I want to talk about his theory of experiments, but that's the other semantics, and I think this is fine for today. And also I can be a little better prepared, so I'm not just scrolling through this. But let's see. Let me find what page is that? All right, so these are some actual examples he gives of like how to interpret the connectives in terms of kind of costs. So he talks about having a $1 coin, it's equivalent having 5 20-cent coins and then 2 things that are worth $1. And then he's got diagrams so you can input that amount of money, which are A and D, to get one of these things back, falafel or whatnot. And then he gives us these diagrams or these connectives. $1 coin, we get a falafel. We can exchange 5 20 coins for a $1 coin. We start with a dollar coin and end up with a dollar coin. Maybe it's a different coin. And so in this case, we can see how the Folsom plays the role of like the opposite. So if these are credits, then adding that becomes a debit. So we have here, we have a falafel and then we are obliged to pay. We eat or otherwise dispose of the falafel. And so then with like duals, we go in the opposite direction. If we eat a falafel, then we can fulfill our obligation to pay by handing over a dollar coin. A debt of a dollar coin can be replaced by a debt of $25 coins. And then we can see that these are places where the cost idea starts to come in. So the multiplicative conjunction is interpreted as accumulation. So this would be equivalent to saying with a $1 coin, we can get $2 worth of goods. So without adding any of the modalities, this is a logically invalid statement. But if we go to the additives here, this is what he calls, pulling from quantum physics, a superposition of states, that we now have a choice between B and C. With $1, we can either get falafel or a donut. This connects over to what he calls experiments, because for him, these choices are something that can't be like determined. And depending on how we choose things, we can then see if things are actually different or not, which is what his experiments come down to, is what testing whether or not things are actually different. Here's an example also of why this notion of idempotent is important. Because it's just a choice, if we just add the same choice again to it, in other words, having a dollar is the same as getting a falafel and getting a donut or getting a donut, that's just a meaningless choice and we can just take that away. We're just adding it. But if we were to say having, if we, for example, had A times A times A, so we had 3 A's and then we had B times C where we had 2 donuts. Those would not be idempotent. Those would be 2 distinct donuts. So here we have the notion of conjunction as accumulation. So this is where we're actually kind of adding a resource. And here we have the notion of a conjunction as a choice, where we're choosing which resource we're going to use. So he talks about we have choices that are internal to the system or external. So in this case, someone chooses how to spend it, but it's external to the money. Here we've got a choice that is made internal to the system. And this is where it's kind of left to whatever it is you're modeling to make a distinction between what is external and what is internal. But again, the idea is that this other operator doesn't signify just adding things. It signifies a certain way of making a choice. And so here's an idea of like how that choice plays in. We can choose between spending a $1 coin or spending a 25-cent coins for purchasing a falafel. Both possibilities are available. So if in the first one you have to like choose one and get rid of the other, this is more like they're a bit more like interchangeable. But again, like how you interpret that depends on the context and whatnot. And so this gives an example of like how the multiplicative conjunction, the X, this is what signifies actually expending resources. So you are A times D. These are the resources you're actually spending, and B times C are the resources you're actually acquiring in return. And this is an example of where Girard himself is like, this is a weird one. And this has to do with the multiplicative disjunction. If these are adding resources, these are essentially like choosing between in like a single spot, according to this interpretation. So, and then the modes are licensed to print money. So we can go on to that. But these are some ideas of like how the four different logical connectors themselves are what do the work of kind of tracking resources. And some of them actually use resources in the sense of like the multiplies, and or choose between concrete things like the and the ampersand here when you're choosing between a falafel and a donut. Or there are choices that are going to be made within the system if you have that, whatever that might mean. And likewise, you have this last guy, which is again kind of weird. So, yeah, I'll leave it on that. Oh, and then just to give another intuition, these are what those connections look like from the phase perspective. So again, when we're making choices, we're actually essentially making like products here where we're actually kind of adding everything up. Whereas over here, we're more like looking at the options we have and then selecting one of them. Yeah, I'm gonna leave it at that. It's already gone on for an hour 45. And leave it for conversation.
Yeah, should we jump straight into conversation or we won't need 5 minutes?
I could jump straight to it if you guys are okay, but let's see what everyone else thinks.
I'm good to go. I'm just gonna grab a quick snack, but we should go ahead and just roll if other folks are good with that. I've got crackly things, so I'm gonna just put myself on mute while I eat them, but I am listening.
Yeah, I'm going over just his like that blind spot book. Yeah, and he when he talks about phase spaces, he makes that very clearly. He says phases suggest an approximate analogy with money, time, space, food, indeed everything that can be styled as a resource. The main quality of a resource is that it cannot be duplicated. In other words, that the rule of contraction does not apply. to such an extent that one speaks of the miracle of loaves and fishes, and that the law severely represses the duplication of money. The notion of resource is less clearly antagonistic to weakening. Everything depends on whether we read weakening as destruction or as non-use. Physics opposes the blunt destruction of matter, and destruction of money is a criminal offense, although possible, but one can decide not to use all the resources. An interpretation in the style of money, consequent B means I have got B free of charge. A, therefore, B means that one can get B by paying A. The tensor product A times B is the conjunction of both, to pay A and to pay B, or to get A and to get B, and so on. So yeah, that seems very, very essential to his representation of the whole thing. And he says, is this serious? Yes, it enables us to represent in a faithful way by means of logical consequence a lot of concrete computational processes.
Is that in Linear Logic, his book, or his?
This is the book, Blind Spot Lectures on Logic, chapter 10.
Oh, is that also him?
Yeah, this is Girard.
Oh, okay, cool.
Yeah, man, I mean, I think that there are two levels to this that one very basic level, which I have a question that is more conceptual, and I do see, I mean, there are many things in what you're saying that I find very relevant, but the points of connection and how to kind of grab them is still unclear to me. But there's one question that I have at a more fundamental level, because I mean, I haven't really looked into these things in detail, you know, much more about this than I do, but I know that a lot, I mean, the connection between systems and environments and interaction, it's very much intrinsic to this. This is not like a kind of an external analogy or attempt to connect things, right? The geometry of interaction point of view, which is something that he invented. The whole thing about questions and answers, like the of course of the exclamation point, right? You just get this. It's for free. You got it. Or the why not? Like, can I add this on the other side as a consequence? I know that it has some relation also to the idea of interaction, in the sense that but I don't know where this is written, but I've read or heard somebody talking about Girard's in Linear Logic in terms of it is a kind of dialogical notion of proof where operations are like the system outputting something, and then the memory of everything that has already been done, or the resources you can use to do something back for a new operation. That's like an environment, right? You even get that idea with the exchange. Like there is an idea of two sides to a logical step, right? When he says like I mean, it even has a nice relative and equivalent form to it, kind of division, because it's not an A, therefore B. He treats the A side and the B side as having very distinct qualities, right? And you can like infinitize one side and not make the other infinite, and you can apply the contraction and weakening to both, or just to one of them or to none of them, and so on. So he does seem to treat these two sides as qualitatively distinct, and the idea of being resource sensitive makes that distinction clearer, right? So you have like credits and debts, and you can work around this to come up with different concepts of negation and so on. So the first thing I'm trying to understand is that there seems to be an intrinsic way in which the distinction between systems and environments is plain in this. That is not, I can't put my finger on, but both, I know that he deals with this directly or indirectly, and I know others have written about it, but I don't know much about it. So that's one thing I wanted to flesh out a bit more, if you have any idea about it, because I totally buy, just from an intuitive side, the way you presented it as well. You know, linear logic is very much connected to the issue of how do systems and environments interact. but systems and environments imply a certain qualitative difference, right, between the two sides interacting. I think that's important. And I do feel there is something like a qualitative difference between the two sides of an implication here, though implication is not exactly where the system and the environment seems to come in, right? I think that he makes that distinction in terms of the accounting of a logical step, right? The place where you would see systems and environments, I think, in linear logic is not exactly as I just suggested, like A is a system. You know, the one side of implication is a system, the other side is an environment to that system, but more like you have the space of everything you can use. That's the environment of the proof, and the proof is the system. And you're taking from the environment. So I do a step. Well, now the environment changed because I spent something I cannot spend again, right? So that seems to be more like it, right? The proof, the actual proof net of steps you take is the output, right? Is the kind of product of the interaction between the proof system itself, so what you're trying to get to, and the available resources. And every time I make a move, I change the resources that I still have to move forward, right? Like it makes a lot of sense to me to think this direction, because it's true. A resource that affords you everything, or a system that can do everything, right? You wouldn't get the idea either of system or of environment if I can get whatever I want to get because I can infinitely use things, and there is infinite resources to use. I can arrive at any resource I need, right? I can reproduce resources infinitely. Like, it sounds like you get an environment when you have restrict resources, you have just those resources. That's like even in, evolutive biology and, I don't know, all this zoology or whatever, that's resources, scarcity of resources and environments are very much connected concepts, right? So, but does that make sense to you or to everyone? Like, it feels like if you want to find the place for the concepts of environment in this, you need to look at the distinction between proof steps as the outputs. Like, you need to kind of look from the perspective where the complete proof is the result of an interaction between a set of kind of strategies, which is a system, and a set of resources, which is the environment. And every step in the strategy uses up the resources in a certain way, so the space of possible strategies is reduced, right?
Yeah, I think there's like two things I'd agree with all that. I think there's definitely more refining in terms of like what actually the system environment difference is. In this case, yeah, I don't think that the orthogonal is as simple as like the input output cost whatnot as you have in the simple models you have from Girard. I think one of the ways that you can start to kind of define the difference insofar as it is an environment for a particular system is when we're looking at that space of closed facts, and in particular the intersection. What constitutes that irrelevant or those orthogonal subsets is going to change. In fact, the overall phase space is going to change from system to system, but in a way, insofar as you could say that, like, let's assume that like the phases are tasks or pieces of like work out in the world, quote unquote. And so people are kind of looking at the same things, but whether or not they fall into like the orthogonal is going to change from system to system. And so you can kind of see the open and closed fact spaces as ways, I think, that different systems kind of provide a topology of what is relevant to it. And there might even be potential connections there with like the notion of a niche, that like the closed facts and orthogonal may have something to do with that process of lower cost. But I do think at the same time, one thing we want to make space for is when we're talking specifically about like MES and hierarchy and emergence and complexity, part of what happens there is you have passages to the limit. And so part of what you get, I think you could argue, out of complexity. And so what we could talk about, like when we have something that develops at the level of like social logics, which are built on lots of other complex thing, is you've gotten kind of quote infinity that has been built into these like sophisticated social practices. So what seems like, you know, a very elementary, and from the perspective of like a social world, a gift exchange is a kind of like atomic operation. But I think what we can do is we can kind of use linear logic to recover the process of building up to that in the first place, that enables us to get a particular kind of like social exchange logic. So we're able to kind of move between a more abstract notion of a world and the more specific kind of social modes that we're getting into. But yeah, I think that requires further refining what we mean by all these fact spaces, and also digging into some of the other models like coherence and stuff. So
yeah, I mean, I don't follow some of that because it's just I don't understand enough the stuff. Like, but just to go back, because I said I didn't say anything about the orthogonal operator. I just wanted to make sure if you think that basic intuition makes sense, like something like this. Like it's almost like there is something like the strategies, there's something like the resources, and an actual proof. In the case there, something that he calls like a path that belongs to path of P, right? It's something like you get some task that takes you from here to here, but to do this you had to so the task is coming from here, and the resources here. You have some amount of A's you can use, some amount of B's you can use, right, and C's and whatever, and so on and so forth, and you're using them up here, right? So this thing here is like this first part here says, hey, I want to get from here to here, right? And then this second, so this is the first step, and then the second step is that the world answers to you, fine, now this costs this amount, right? And then you want to do something else here. Oh, but this, if A goes to B, therefore, you know, I can say that A equals C or whatever. Well, and then this says, fine, you want to say that this costs so much, right? So you have like a system and environment kind of distinction as the interaction between these two things is actually, you know, what's steering what proofs are possible and what is an effective proof or what is not, right? You see like the underlying, even if it's, I'm sure it's not exactly like this, but you see the type of, the only place I can actually see thus far where the distinction between system and environment is coming in precisely as where you said, like there is an interaction here. So where do you see this distinction coming in with a way that keeps the distinct qualities of these things? Well, it's where I see it is if when you have this thing here, right? And actually, I think it's Julie, no, Jennifer, right? She writes this Hasse diagram like this, right? Right, G is this path here, right? This path G, it is actually a mixture of something that is coming from the tasks or the thing to be proven, right? With a cost constraint coming from the available resources. because we know G would change both if I wanted to get somewhere else and if my resources were different. These two things would steer this, right? So you get this interactive, what he calls a feedback equation in the geometry of interaction. As a sort of, so this is like the geometry of interaction point of view. This is giving you, let's say, the infrastructure for this linear logic description here, right? Or this doesn't make any sense.
No, I think that makes yeah, that all really tracks. And I think one of the things that's helpful is that whereas like the one is like part of the overall like P's, and is like quote like in the world, that other subset of the absurd P is going to be kind of indexed by what the strategies are, right? So you're going to kind of be able to kind of, you can almost see like how they fall on different sides, right? Like that one signifies that you've actually kind of like gotten to some place in the world, and it kind of indicates like that feedback. Whereas depending on what your strategies are and your objectives, it will then kind of determine what in the world is actually relevant to you in the first place. So you kind of, have these different sides that are built into the logic. And I haven't read as much of geometry and interaction yet. I need to get into that because I know that's where a lot of
it makes no sense to me. Like it's not like I understood what the fuck is there.
Are you reading the actual geometry or the one I shared?
No, I just opened Gerard's book and I read the first page of the feedback equation.
Oh, the actual one is fucking insane. Yeah, I tried to read it and I'm like, no.
So I got something. I got something.
But the one I shared towards the geometry of interactions, like him explaining it to dumb folks like us. So that one's good.
Yeah, because I mean, so my first intuition has to do with this idea that, okay, linear logic is actually happening at this level here. And it's already using the concept of resource to limit and steer the concept of proof strategy, right? And then because of resources, you can distinguish between efficient or relevant, right? Or how did Dennis said, like, effective, right? It's just using what is necessary. Effective and non-effective kind of, which uses orthogonal stuff, right? So you because you have the idea of resources, you can make this distinction between the strategies and so on. And probably there's stuff here which is beyond our pay grade right now that is helpful to actually spell out, because there is the logic itself, there is the dynamic itself between these two things here, which is kind of a question and answer kind of style, right? Like I say I want to do something, I propose something, I get a consequence here, and this affects what else I can propose afterwards, and so on and so forth, right? That's not exactly the logic of the proof. This is the logic of how strategies and resources interact behind the proof, like the underlying machinery in the proof's motor, right? But this is, I'm just touching on this so we can go back to the other thing, because what is interesting here is that it does have an inverse. If this is true, there is an inverse relation between this and what we've been saying. I mean, there is something about resources that does sound like affordances, right? Does an environment affords you something? Does it allows for a path? So it does connect, right? But there's something that we've been trying to track on the other side, which is the compositional constraint of the system in saying that what the environment affords is related to the compositional constraint. So if you have a system that is like a anarchist collective composed of people of a certain type in a certain place and so on, the way that they see their environment will be defined by that, right? That kind of sounds to me like our concept of this correlation is like derivative of an original, or like this is my point. Like I'm having a hard time knowing what comes before, like a statement of the sort. The way systems are put together limits their environment, like warps and constitutes their environment. That sounds very constitutive to me, right? And then what you're saying is something like, well, if I only have an eye that has a certain physical property, well, whatever frequencies there are out there of photons and so on and so forth, I will only be able to process some of them and not others, right? So there is a limitation of what I get to process, what I get to verify from the world, right? What type of facts I get to prove based on my composition. But in linear logic, it looks like the limits to what you can prove are always coming from the environment. Like logical systems, you know, if you could give them infinite stuff, well, they would prove anything. Like they would be like pure classical logical machines. So there is that's where my doubt about how do you connect this, even before going into the different logics, which I think it's a separate point, right? Even before we get to the fact that these environments and the systems can be intuitionistic, classic, non-classic, and whatever. Even before that, there seems to be this underlying distinction, which is we have like a concept of object that goes here and that does this, right? Our objects are composed in some way that makes them a system rather than another, but because they're a system rather than another, they are going to warp what's not that object into an environment of certain properties, right? So it's kind of like there are constraints on a system and there are constraints on an environment that are kind of co-produced. Whereas in Girard, it seems like systems are not constrained, and every constraints come from resources which are part of the environment. You know? But yeah, I might be going very far into something I just don't understand enough. But this is also a way of just stating something I wasn't very clear on, and I'm a bit clearer now. That is my problem with him, with his metaphors, which are very interesting metaphors about resources, but they are very fetishized. Like, you know, what you want to buy is always material, and what you want to use to buy it is always like symbolic, like coins. Like he treats them like, yeah, but one coin is different from another. And I bet that he loves to think about that fact, that every piece of paper money is actually different from another piece, which is fine. It's a nice insight, but he doesn't take like examples of effort to get something done, you know, which I think are much more clear, that all parts of the equation are constrained. In one case, it seems like you have like this subject and you want something, and to get something, you need something from the environment. And do you have enough of that thing or not to get where you want to go or not? I don't know. There's something to all of this that is a bit. We broke Maurice. I'm sorry.
That's okay. I'm sorry. My brain is also almost broken, so solidarity on that.
All the power of his life. We weren't resource sensitive, and we consumed all the electricity in most house.
So I think there's a few different things. Like, just at the level of the logic itself, this is the difference between the ampersand and the direct sum. So the plus with the 0. It's on page 75, 74, 73, 4, 5 in the Lazy Logician's Guide. Which is that there is a distinction of choice between something that is in the environment and something that is from within the system. That's built into those logics. And so I think part of that is like, that's what I was trying to say at the beginning. I think like linear logic itself is a generic logic of a systems interface. So it's in a sense not going to be as specified from the perspective of the system relative to an environment, not because it's trying to make the final say about system versus environment, but specifically because it is an interface for the system to its environment.
But that makes sense,
said,
man, because there is no such thing as a logic from the standpoint of the environment.
Yeah, but that being said, I think part of where you actually constrain the system is how you populate the phases themselves, right? How you populate facts, how you populate the absurd, how you populate the topolinear spaces. Those are what, because while those phases themselves may be kind of points in the environmental space, whether or not they're determined to be orthogonal will come from the system. And I think that's where you express constraints of the system proper, right? Because why is it orthogonal for the system in the first place? So I think that's where it is. But yeah, it is kind of left to the what is that, the generator, you know, what you actually plug into it in the first place to determine that. But once you do that, then yeah, you get some really interesting distinctions between external choices and internal choices, which may in turn be useful if we start to think about the questions of like, you know, we start getting into around nested systems and environments. Like what happens when the encampment is treated as the system relative to the overall environment of the campus and town versus when different groups or individuals are systems within the environment of the encampment, right? Like, so there might be ways to kind of like track those differences. I'm not sure. I mean, this is where it all gets pretty crazy but one of the things that I know, even though I haven't looked into yet, is because this is coming from computer science, linear logic does have lots of connections to like abstract, you know, hierarchies, like keeping track of different levels. And so I think, you know, some of the questions of like, when is something a system relative to an environment? When does an environment itself become a system? What is a part of a system for another system, or blah, 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 right? Like, I think a lot of those questions can be, because I think that's where, you know, it's not linear logic, but rather MES that actually gives us a lot of the rules, right? So then the question becomes, how do we encode in linear logic constraints coming from a more specific field like MES? And just to be completely shameless, that'd be a plug for the next talk when we get back into adjoint semantics and poles and parts and blah, blah, blah. And yeah, that'd be a good question to kind of specify too, is what that would look like. So.
Yeah, this was amazing. I mean, it's really a lot of connections with, like, I feel like we never had a concrete, you know, cognitive map of what linear logic would be for everything we've been building in STP. But now I feel like it's a lot clearer, like where that should go, even if we don't have the technical, you know, fine points down. I feel like we can say for sure now that linear logic has like a very crucial role to play. And I was thinking also talking about the encampments, there was one thing in particular that you said in your presentation on them that I thought it kind of clicked with me when you're presenting the linear logic, which is that there are some facts about the global struggle which people were kind of hastily bringing into the encampments, but there was no way to actually like verify or make it have like a real consequence to the daily decisions that you had to make within the encampments. And it seems
Uh-huh.
like that resides in this space, right? Of like, you know it to be true, but like because it doesn't have any work attached to it, like it just kind of
Ah,
is free floating. Like you have these free floating facts about the whole world, but then when you're actually in the, yeah, you get it, right? You're in the midst of organizing, those free floating facts don't necessarily contribute anything. So yeah, I think that might be a interesting case study of this method.
so you're talking about like KNL here.
Yeah, yeah, exactly.
Yeah, no, that's actually, yeah, that makes a lot of sense. Yeah, because you're not able to like have any kind of like process that tests them out, like a task that actually says, okay, this is useful for us or not. This actually advances us. And that ties also to something Gabriel was saying, which is like when we're looking at the kind of field of the like the encampment and the campus, like what is the minimal thing we need to make appear to kind of like organize around or to kind of like raise a certain level of pressure, and not being able to do that, I think, is kind of like having these K's and L's free floating as well, right? Like we're not able to kind of like actually like determine, in a sense, the gap between what is and is not relevant to the larger student population, right?
Yeah, exactly. And when we say relevant to the larger student population or relevant to the people within the encampment, it's almost like in our situation, what verifies a fact, maybe not in all cases, but usually it's like a person, right? Like there's a person who has to do some kind of work, or they're constrained in some way and they feel it. And maybe it's not felt by everyone, but it's felt by this person. And that's what we call verification in a social sense. Um,
Yeah, I mean,
I was thinking, because there can be facts that no one really feels. Like there can be a fact about some place around the world, and you can say that in a concrete situation. You can say the fact, but it doesn't really constrain you or anyone you're talking to. So like verification has a very different meaning here. But yeah.
yeah, I think that there is a distinction here we should make, because what you guys are talking about, I think it makes a lot of sense, but I mean, I don't think we would call them facts in our language, because they have to do with points in Badiou's parlance, right? Meaning like observations about the world that are relevant for politics are not necessarily just empirical observations, right? And they do add a problem that you don't need to. I mean, I think that there's a very good connection with that example of, because we were talking about, for example, big conjuncture analysis. For example, a statement like there is a connection between the campus police and IDF. That might be true in a very broad sense, where you get like funding, training in common, similarities in procedure, common objectives, or like stalling the movement and allowing genocide to continue. But for the system, which is the encampment, is there anything you can do that verifies that proposition, right? I think that's what you guys were talking about, that distinction, right? Which I think in the conversation we were having, that was more based on the environmental logic thing, which is more like a phenomenological discussion. It was about, does that proposition name anything that appears for the system, right? Is it part of the system's environment, in the sense that, does the system, better said, does the environment, meaning the encampment, and then it has the university campus with the police from that state and the police officers and so on, does that environment afford that statement? Can you get to that statement to be verified by the interactions you would have with the police, right? Would at some point it be observed through that interaction that, yes, indeed, this policeman have something to do with the IDF? Or will every time that seems to be true, the inverse statement, they have nothing to do with the IDF, they're just morons, would it also be valid? And most likely both would be valid, right? It's hard to think from such a local point of view, a way of interacting with the police that would, either uncover the financial pipeline that funds the IDF, or that, you would have to step back and have a bigger system and have a different context to be able to produce that in a verified way. So verifying a statement and the environment affording you that appearance, right, which for us is an objective thing and not a subjective representation. There is some connection between these two things, right? Proving with the resources of the environment and proving with the available resources and interacting in such a way as to make intelligible from the standpoint of a given system and a given environment. That's where the two things are converging, right?
Yeah, I think this is, yeah, I wanted to get into this actually more than the phase semantics, but I decided to stick with this because it is simpler than the other ones, and also I'm still wrapping my head, but there's another relational semantics that's built off a generalization of the Kripke frames that are used to model modal logics, and those use a kind of like similar to that, like a notion of world and then like information quantum that comes out of the world. And one of the things they do to build that is something called canonical extensions, which the way I'm interpreting it is essentially taking any kind of like space of affordances or whatnot, and then kind of like filling it out to extrapolate like the points that are relevant based upon whatever kind of like algebra or set of rules you're like applying to it. So in a sense, this other semantics, I think does a better job of actually showing how linear logic, essentially like in order to get a model from an algebra or from a lattice that it fully captures linear logic, you have to canonically extend it. In other words, you have to kind of like populate the space of like operations with all of the points that are relevant to that like way of like operating, right? So if we're thinking of it as an algebra of like combining things to feed yourself, right? The interface works when you have an environment that appears with all of those points kind of like present. That doesn't mean you have like all the information, but what it does mean is given the information you have, you've kind of like, quote, completed it in a way that lets you kind of like map it out. In a sense, I think it's a way to kind of think through what cognitive mapping does, is it doesn't like just simply represent perfectly like the world inside your head. It takes information and then fills out the gaps to get a complete, if not fully like correspondent picture. But that'll be something I have to go into more next time, which works better because it fits better with like parts whole semantics from Mariology. But yeah, no, I think that's very much like that question of like objective phenomenology and of points and of determining how, because essentially the points are like joins and meets of kind of lattices that are projected into the overall like space of appearances. So there's a lot in some of the models that are actually pretty close to like Topo's theory and stuff, because there's all these like weird overlaps. Phase semantics is not the best one though to show that, but I do think there are other places that are closer to the theory of points and whatnot. Let me actually.
No, good, but I'm saying this because I think you made the connection much clearer than it ever was. That I think phase spaces, phase semantics actually is very clarifying of that as well. Because I was just suggesting that why does it seem to relate to points? Because points are work on two levels, right? On the one level, it's about information through interaction, but on the other level, it's about partitioning the world into connective and non-connective stuff, right? So that duality between moving forward to interact and make something intelligible and perhaps in this language prove something, and the fact that that proof redivides the world into different partitions, right? Connected things that are relevant to this, right? That sounds to me like it is more resource sensitive than it seems usually when we talk about points. Because, right, it's, for example, if you come up with a collective where people who never meet manage to be in that space, people who never engage together on anything, they find some commonality in that political struggle. You would say, well, this is a point to decide to engage with those people we never meet, like students and workers meeting to discuss the revolution. There is both the fact that, you know, it's only possible to move forward if that alliance is produced, but the fact that that alliance is produced also makes the connection, the subset build of students and workers, a relevant resource, right? Where one might say, no, you don't need this type of thing. From the standpoint of that struggle, you wouldn't make that partition. No, this is what Badiou calls an investigation. It's a connection between subsets of the situation that you wouldn't make if you were just trying to prove the facts, right? In the regular Badiouian sense of facts just being kind of appearances projected onto the multiples in certain conditions. So there is something to that theory of points that it has this similar thing. You want to build a topology inside of the world. It must respect and preserves like the basic structure of the world, but it also needs to connect things in a way that weren't connected before, in such a way that you can divide the body from the world, right? There seems to be like a procedural description of this in what you are presenting.
Yeah, and if you want to go down the madness, one of the things I liked about the PDF I just shared, first off, the last section does relate it to phase semantics, so it will tie it all into this. But also, one of the things the authors emphasize is that it's more modular in the sense that you kind of like, you add on different pieces with each of the, you know, as you add on a new relational structure, you get new operators and whatnot. It's very one-to-one. And to me, it gives a really good kind of like description of what the kind of layers of building an environment for a system would look like. And so this isn't necessarily, again, like an environment as it might be described if we were to start from the perspective of like MES, but this would be like what essentially like an environment would appear in the sense we mean of objective phenomenology for any given system. And it starts by kind of like taking a kind of relevant graph of, we could call them affordances, or procedures or tasks, fleshing it out into points, and then systematically building structure on top of those points in order to enable a more like sophisticated interpretation and kind of manipulation of the information, blah, blah, blah. But yeah, no, I think that this is that essay really reminded me of Badiou the whole time I was reading it. So
yeah, because I mean, just to go back to the point that has to do with this, but just to try to make it clear, I think that what I think that you're touching on, and the fact that Dennis brought up the encampment meeting, the thing that I think you're bringing to the fore that is we don't have a theory of. Like we have a theory of the fact that Like we have a general abstract statement that systems of a certain composition can only make certain things in the environment intelligible. Because if you're built in a certain way, you can only see certain things, right? That's our abstract statement about systems. We give like some logical content, logical meat to this statement by saying, well, a system that is a company that is built on certain types of affinity, certain types of property laws, certain types of organic composition of capital, blah, 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 blah. It will deal with its environment as if it's just, affording value to valorize itself, and people are there to afford this itself. So there is a warping of the environment built on that system's composition. Well, if you want to experiment, intervene, or inquiry into the world about new compositions, interactions, intelligibilities, you need politics, right? And that's a second abstract statement, that political organization will make new things affordable in the environment. It will afford this new intelligibility. But the logic and more than the logic, the constraints on, okay, not every new statement is a verifiable statement. So for example, what I wanted to get with the example, so we come up with a small, like S2P, we managed to in practice kind of go through the steps to show that you can only get to certain places in theory if you mix it up with the people, the procedures of how you do things, right? We are able to go in a direction that if we were just an academic study group, we probably wouldn't get, or if we're just like a regular Marxist study group, we wouldn't get, things like that. But does that mean that we can prove the statements such as communism will win? Is it a real statement in the kind of interactive space of our political movement? I don't think so, right? Like when you wanna get to that point of view where that's a concrete statement that you can get to, you need to imagine a much larger system composed of many, many, many things. We hope S2P is part of that bigger ecology. And then that statement is, let's say, in the purview of that big movements, interactions with the world. So when you get to that discussion of, given the restriction of a system and given all we can interact with, there is a certain phase space of paths that you can get, like where your strategies can get you and what the world for that system affords that system, right? So it feels to me like this is the realm where what you're saying is getting to, which is, it will be, like if you pull this thread further, it will be already much more concrete when we should be able to say something concrete about, well, companies, it's no wonder that they keep an accounting book of, the resources they need to get somewhere, and it's all commodity based. They're built for optimizing value and valorization processes, so they track everything that valorizes or doesn't valorize things. And every step correlates with a cost at the level of commodities and money, right? So you will get we should be able to pull this thread and get a concrete picture of, given not only some structure, but given also some affordances for that structure, let's say it's the concrete theory of the warping of the environment. Well, you will get some places, but you won't get other places, right? It's like your provable space for that system, for those, like the concrete strategies out of the abstract strategy space. And when you get to politics, you should get something that's similar, but even more singular, because you can't simply keep track of logics like mode A, mode B, mode C. You need to keep track of like concrete propositions, right? Like equality or unfairness in the workplace, or lack of equality of genders in payment or whatever, or anti-racist struggles. There are propositions that are like there are the abstract propositions that we maintain in our heads, but there's the actual propositions that are built into the organizational structure. And those concrete propositions are the actual ones that are limiting or expanding what political organizations actually get to do. It doesn't, so you see, like, it feels to me like what you're investigating is how to give more meat to the concrete strategy space of concrete political organizations in a way that we can distinguish unverifiable but true statements that we hold, that we can only hold them in infinity, which is cool because that's what we inherit from other political movements, right? I say to be part of a political movement is to borrow some infinity to prove things, isn't it? Like, how do I know communism will win? I don't have the money to pay for that statement, right? But all communists together, we pool resources, and then we have infinite money to say that. But a given organization, it doesn't have that resource. It has resources to say something like, we can stop people from getting fired. We can revert a racist bill. We can stop funding Israeli military. That's, let's say, a large but finitely funded proof. Whereas some things take infinite resources to prove, or at least inaccessible resources from the standpoint of a concrete group. So I feel like what you're doing has a lot to do, like the underlying intuition behind what the connection you're proposing has a lot to do with, that's why I call the political economy of points. Like, you want to be able to tell apart not only, well, militants think they are like generally communists, but they're actually a group of X, Y, and Z people meeting in X, Y, Z place to do X and Y and Z things, not everything. So those restrictions, they are the thing that we think about when we think about social reproduction, the organizational point of view, so on and so forth. But we don't have an organizational theory of strategy, meaning the really existing strategy of organizations in kind of contrast to the abstract things we would want to do, the places we would abstractly want to interact with, right? And I feel like resource-based logic is telling us that, well, abstract strategy is infinite strategy. It's strategy where you have infinite resources to get from point A to point B. You might still not, it might be still logically unsound, and therefore it's a bad strategy for purely logical reasons. But there are other reasons why something might not be admittable. It might simply fall beyond the resources to verify that, right? Like it's not provable in polynomial time. Like you can't compute it to the end, right? So it's that's a new distinction. I don't think we have anything like an organizational approach to strategy where we can talk to movement, which is exactly what we were talking about with encampment. Like, is it fair of an encampment with scarce means to think strategy in terms of, disbanding, like sanctioning the IDF or sanctioning Israel? Like, are there enough resources for that? Or is that, let's say, infinite in this bad sense, right? I wouldn't call it even infinite, because I think that as a communist, I think I need to separate infinities you can access from infinities which are more in the Girard sense of this is bogus, illusory, essentialist logic, right? But it's just inaccessible.
Yeah. So I think I also got to go here soon too. So I'm just going to toss a couple things out. Amongst the many other models for linear logic is one called abstract games. And Hyland talks about how you can then concretize the games from that. So that might be an interesting thing to actually look at strategies. But yeah, linear logic is used with that. And then I think one thing I've thought about might be an interesting way to interpret the modalities is to treat them like when we talk about thought without thinkers and about how organizations think, that when an organization thinks, it's capable of actually like effectively setting one of those modalities into play. Girard talks about how the modalities model situations where the non-modal phases model actions, right? Like, and there's an action and a reaction. But here we're talking about a situation. So we could almost see like a company does keep track of everything and writes it all down. But what it's capable of doing is it's capable of kind of like infinitely refining how much it wants to approximate, you know, minimizing the cost, maximizing the return, right? It gives itself like a certain amount of like ability to think that process. And again, like I don't know exactly how to translate the sequent left-right-handedness to all the actual exchange relations, but I think that there might be something there, especially when we talk about like the binding problem and complexity emergence in MES, that organizations essentially acquire the ability to suspend the cost of one of the social modes. And you know, are able to kind of look at things from that perspective. Because it does, you know, a big, you know, one of the questions is like, how can you have, for example, if you've got a world in which all the social modes are present, why is it possible that like Marx's, you know, analysis of capital is not only compelling like for the whole system, but actually generally gets the quote like organizational psychology of any corporation down pretty well, right? It's because an organization, like a corporation, not as like, you know, the individuals even on the board, but rather what the corporation itself is doing is it's capable of kind of like infinitely taking into account the kind of like reasoning of open sets, the kind of reasoning of mode C. And so we can kind of talk about like in a sense where like infinite in that play on like the notion of thought and thinking about thinkers and all that jazz.
Yeah, because yeah, man,
Yeah,
this is
I think I made
amazing.
my. Y'all like it? Good, because I had no clue. I was just really hoping it'd be useful. Ergodicity.
Man, this is so cool. I'm gonna look into it. Ergodicity.
Yeah, that is cool. I will also be looking into it.
Well,
yeah.
I was gonna say, like, if I were to just give, like, since we're in the moment, like, last minutes of making big provocative claims, we can hold at all.
Do it. The most ambitious.
I would say, like, because there's two things there. The first is it's funny because Girard uses a lot of metaphors with money, but money is a double-sided thing where it's finite in quantity, but infinite in what it is exchangeable for, right?
Yeah.
Like Marx makes this statement about the kind of dialectics of limited and unlimited in the case of money. It's unlimited in the case it can exchange for anything, but you always have a limited quantity of it. Which I think it's
Oh, that's interesting. That would be a way, like, in other words, the output is in. Oh, that's interesting because now you have money goes in and you have on the output an infinite range of kind of things. And on the other hand, you've got like the gift itself is what can take on the infinite range of possibilities. So the input has that kind of something like that might work. Yeah.
right. And then that's the first intuition I
Yeah.
was having. So we can recuperate the idea that intuitionism gets infinity on one side, but not infinity on the other, right? and I mean, fuck, man, like the actual formulation, the actual implication from the formula of value is precisely that money is the consequence of everything, right? This is how you get to the universal. You can put any commodity and express it in terms of money, right? So finite consequence, but infinite premises. Anything you can put can give you a very specific thing, which is a certain quantity of money. Whereas with gifts, of course, like, as you said, the gift is the thing that can be anything, right? Whereas money can be only one thing. So there is something to that, which I think there might be a way of showing that this asymmetry between infinite resources on one side or another, giving you paraconsistency or paracompleteness. We might be able to get to that. And then there is another aspect, which is the scalar one you were talking about now. I wonder if infinite resources appears, for example, in a company when something is below the site, meaning when you cut the level of intelligibility at some point and you just throw it below the atom, that's when you think you can just suck the life out of it infinitely, you know? So for example, to go back to Dennis, the thing that Dennis was studying with social reproduction, it feels like there is a resource sensitivity in capital to wages, but no resource sensitivity because wages go up and down according to competitiveness between workers, but demand, blah, blah, blah. But the intensity of domestic work necessary to reproduce, turn means of subsistence into the reproduction of the worker, that's not quantified. It's like infinite community power, right?
Mm-hmm.
Because it's kind of below the site, below the minimal atom of the productive sphere, right?
Mm-hmm.
So that would be interesting because co-limits are like taking the form up in the scale, and limits are on the other side, right? As something you're not, like, you're leaving behind. You're no longer computing what's below.
Interesting. Yeah.
So there could be something to that in a way of explaining why, like, in this composition of logic, some things are forgotten, some things are considered infinite. And two other things to keep in mind. One is that, I mean, I think Girard is like clearly an anti-philosopher. Like, I think he's like a ridiculous genius that everyone needs to go through if you want to keep on thinking about logic. But I know in my heart of hearts that he's just wrong about the philosophical kind of consequences of what he's saying in terms of what, classical logic is bullshit and blah, 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 blah. Like, yeah, good that it's like very Marxist, like you're showing all the infrastructural steps into taking like a basic classical logical step, but that's not the same as showing it's useless or illusory or whatever. The reason why I think this is relevant is because there is a deep connection between having infinite resources and thinking, right? I don't think it's for nothing that Badiou has a book called Infinite Thought. Like, reasoning is resource sensitive. Thinking is not resource sensitive. Thinking clearly has to do with the actual infinity. Like, at some point, you realize something about the whole that you could never cover stepwise, right? It's not reasoning. Like, ideas are not reasoning. Ideas are like a point at infinity that make everything intelligible. And for example, a good refutation of what I said, right? You cannot organizationally reason that campus police is connected to the IDF. But keeping that idea in mind might give you intelligibility about points you wouldn't find otherwise. Why focus on the campus police? Why focus on the way they're repressing? You're not going to empirically prove or verify the connection between campus police and IDF, but that's not the point at all sometimes, right? ideas are not the same as proofs. They're not constructible to start with, right? That's why, like, if somebody gives a proof of love, by consequence, you didn't prove it, because it's not about proving, right? Like, if you try too hard to prove you're in love with somebody, the loved one will start getting suspicious, because the idea that you're in love is something you take at once. It's a totality. It's like an actually infinite. It's not like stepwise reaching a conclusion.
Well, this is where this gets really interesting then, because in the relational semantics, when they take the step from just the logical connections to the modalities that enable infinity, they stipulate that the joins and meets have to be irreducible. So they have to be their own standalone points and not just descriptions of them. So in order to actually introduce infinity, you also have to have like this kind of like singularity of the points kind of established or something. I know there's something Baduvian in there, but I'm not quite.
Yeah, that sounds
sure.
very interesting. And just one last thing, again, on the side of crazy things, you know that there's a lot of literature today on ecology and like ecological ethics that is about the value of environments, of natural environments. And their whole point is that it's much better to reason as if they have infinite value than large finite values. So they are reconsidering the necessity of including actual infinity in those very boring analytic philosophy calculus of, you know, how to weigh decisions and so on. Like, it feels like there is things you can't proper reason if you don't axiomatically add infinity into the mix, you know? That seems relevant in some weird way I can't account for. Anyway.
Yeah, I mean, in a sense, like it's as boring as like as how calculus does it, right? Like when you are reasoning to the limit, whether it's to like scale down or to scale up, you're just jumping a dimension, right? Like it's a discrete level of like hierarchy. You know, if you're going in a line across a two-dimensional plane, you can find a point that'll like tell you what your acceleration is, and you can generate a plane that'll tell you how much your distance is, right? But like they're like logically hierarchical steps. So it seems like similar to reason that when we talk about like co-limits and binding, that when you jump up a level, you should get something like a kind of like infinitary point of view on the lower level, like not as some like crazy wild thing, but almost as like that's automatic. That's what it means to jump up and down a level, is to get like, is to be able to reason as if infinite, you know, kind of situation. Whereas, you know, a city has such a level of complexity that you can logically reason as if it's infinite, because in a sense, like, especially in the sense we're talking about, it is infinite. It's generating kind of like emergent phenomena that are not reducible, blah, 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 blah.
Yeah, I mean, I mean, there's a huge discussion to have about that. I do think that there is good reason to separate infinity from higher order, because you can have, like, if I have a set of 3 workers and a manager, you can define like the manager as the co-limit of the interactions between the workers and get like a, you know, cluster and blah 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 blah, without having to go, like, there's nothing that the manager needs to be logically that implies you need infinity to model that. In order to get, you can have like hierarchies with finite sets, right? But that imposes limitations. If you want certain qualities, you do need that point that kind of totalizes things to have the property of being infinite. And then even more than that, there are different infinities, and then you get different qualities of the relation between that point and the ones in the lower part of the hierarchy as well. I would.
But you could also make it kind of almost a banal infinity. Like take for example the you know, the annoying like micromanaging manager, right? Like in a sense, what that manager is doing is not having to deal with the costs of constantly trying to like evaluate things in terms of how closely they can like squeeze into like an infinitesimally kind of like small added value, subtracted value, whatnot, right? Like what's lost is, as is often pointed out, precisely like all the human, all the things that still actually cost the manager effort to learn about, like the actual human connections, the community connections. Sometimes in terms of mode B, even the rules of the business, which often workers have to learn better than their manager. So I think you could argue that the infinity is not necessarily like some great gain in terms of like automatically providing like important insight. It reveals like a drop off in cost in a certain kind of like certain kind of like logical question answer approach.
Yeah, I don't know. I would have to think about that because, yeah, that it sounds like a metaphorical meaning of infinity, right? Whereas before you were talking about like, can you add terms to a logical sentence infinitely on the side of the sequence, or can you add terms to the consequent infinitely and so on? And though that doesn't seem like metaphorical, that seems like actual.
Well, we could look at it like in the way that like a manager breaks down work time, right? Like they're constantly breaking down a person's like time at labor into smaller and smaller units, each of which would be like an additional kind of like packet of time that would be like kind of broken out. If someone's putting in labor time, the output, which could be infinitely chopped up, would be the attempt to infinitely chop up that time into like a readably valuable point of time from the perspective of the manager, right? Like now that may not actually make sense anymore. Like it may like break the process. And I think one of the things that's like you can generate, just because you can generate those statements infinitely doesn't necessarily mean you add useful proofs, right? And in fact, you could, in theory, just keep generating those statements ad nauseum without actually being able to do anything about it, blah, blah, blah. So yeah, so I guess like I think that there's a few different ways to interpret the infinity, some of which are more or less like enticing or like exciting. And I think some of those infinities are actually fairly like boring in a way.
Yeah, no, I mean, we can talk about this later. It's just because, let's say, I think that there is we're right now, we're minimally committed to the idea that things that happen in a world are finite, and the totality of the world is infinite in an analogy with an inaccessible cardinal. Right? So
yeah. Oh yeah. I don't know if the infinity of these modalities is that infinity though, is what I'm saying.
yeah, this is the weakest infinity, right? I would start, and I think that it's a good premise because that's also part of social worlds. Like, like economists love that little saying, which I hate, that economics is the art of connecting infinite demand with finite resource, right? Everyone wants everything, but we only have this much to go around, and then society is trying to solve this problem, right?
Mm-hmm.
I think that there is a good sense in which our social logics are economic logics, insofar as, because they are expanded circuits of social reproduction, right? They're socially expanded circuits of human reproduction, that they are starting from scarcity. They're starting from not scarcity in the sense that there is too little. There can be abundant, but abundant, it's still finite, right? And infinity is only allowed in, at this point, at the closure of as the system of needs, whereas the fulfilling of needs is finite, right? So it's infinite in time or whatever. It's infinite historically speaking. And then politics is something that tries to break with that. Politics is all about, like, no, I don't need to wait for, I don't need to solve economic problems or to solve things economically with this immediate resources to have like this inaccessible relation to infinity. You can actually reason from infinity to start with, right? And then I think things change. It's not the same infinity you're talking about. That doesn't change the fact that you have finite resources.
Yeah, now that you're talking about this, I think maybe one question I'm going to look into, and this will take us all the way back to things like forcing and constructibility and blah, 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 is like how this connects to the question of worlds getting bigger and smaller. Because that's really where politics enters formally for us, right? Is like the social is the world on like an ID functor, right? Staying the same size. And politics or counter-revolutionary politics is making it bigger or smaller. And so that might be an interesting question, is like the relationship, if what there is between like these infinitary operations in the modalities and linear logic, and then the actual process of building worlds larger, smaller, and blah, blah. Yeah.
Yeah,
that's a good spot. Also, my brain's about to melt.
Yeah,
so.
Let's go, guys. It's
But thanks for listening to all that. I really appreciate it. It's good to work it out and get feedback.
No, man,
It's
this
helped
was
make
amazing.
more sense of things. And I'm also appreciate the patience for any of the folks that are less mathy. So thank you for letting us nerd out a bit. What's next week? A book thing again?
No, we don't have anything next week. The book thing we delayed just because we didn't get an answer from Verso. I'll just take advantage of the fact that some people are here. Just say something really quick. I mentioned this on Discord today. I don't think anyone answered. But on the 25th of June, so in about a month, we were thinking of making a second Common Space of Organizations presentation to give you guys like an update. But the idea was to do it with the people who have been joining us at CSO.
That'd be cool.
But we would only propose that if people are going to come. And there are two problems there, because we meet on a Tuesday, CSO. So the easiest way would be to do it on a Tuesday rather than a Monday. And we wanted to check if there are enough people on STP who would be willing to join, because it would be like, kind of catastrophic if we tell the people there, we're going to create a bridge with STP. You guys are going to meet the guys from STP, and then nobody comes. That would be like shitty, right?
Same time?
Yeah, same time, but on a Tuesday. I mean, we can talk about it next week and on other meetings, but
I'll try to keep that open.
Yeah,
sure.
just so.
What's the language situation going to be?
We would be speaking in English, and people who don't speak English who are present, we would translate whatever they say. We would make but we would make a hybrid meeting. So we would all be in one camera at the CSO space, so you guys would see everyone in the room, and everyone from STP then would be online, right? No, a CSO is the Common Space of Organizations, is a in-person group that we host here in Rio, where we present STP's work and develop connections with other political movements. We did a presentation on this, like just giving a general idea of what's this here. I'll post the link here for you.
It's so cool. I now want to try to start the same thing here.
Yeah, man, and I think that Travis, yeah, it's an okay day. Great. Yeah, so it's been, because things are changing a lot. We're developing a lot of really cool connections. Like for the last month and a half, we've been working on a solidarity kitchen here in Rio, just for the sake of making developing our theory of militant inquiries and so on. So we think that there would be a lot to discuss,
Yeah, and also, and we can also table this for future consideration. I'd really like to put something together as like a joint presentation with the student DSA I've been working a lot with.
That'd be amazing.
to do a report on the land movement, whether that's like y'all reporting on it or actually having members of the land movement there, and then connecting it to our own housing movement and the homeless movement. So it'd be folks from a couple different sides talking, and then maybe one of the things like STP could do would be to kind of like frame the conversation. So we've got folks in the United States kind of reporting on things, folks in Brazil, and then like how do we kind of like, because one of the things I gave a teach-in at the camp about the Zapatistas, and one of the things kind of thinking about what you said when I brought up like, you know, how the core learns from the periphery is like, we need to learn how we learn from the global south. And so I think maybe like how we formulate that question and like what it means to have a conversation back and forth in terms of our theory of the periphery, scale, sensitivity, all these other things. I think it could be a really good opportunity on a lot of levels for us. And also these kids are great, so I'd love to just plug them in. Like they're awesome.
Also, man, like it's a good connection to make with CSO. Because we pitched after we had the meeting about the encampment, I pitched to a student strike that is going on here in Rio, that they might be interested in talking to you guys just to have like an international connection between students' movements, you know?
Oh, that'd be so dope.
So I mean, just to say, like there are things we could do in that direction. But anyway, let's allow our brains to rest.
Yeah, Noah, please attend any and everything.
And Noah, please, yeah, exactly. Please feel free to join anytime you want. If you're up for it, we can add you to Discord as well. It's been useful to have that platform. I'll just gotta put my number here, man. If you wanna message me later, we can talk these things out. Like on WhatsApp or something.
Cool. Well, yeah, thanks again everyone for working through that stuff with me. I feel, at least I feel more clear. I don't know if everyone else's brain it feels less clear. But it's yeah, this was
but anyway, really Girard hates transparency, so I think you're
that's true. In that sense, he's a typical French academic. He's like, why make things clear when I can make a living making them incredibly unclear?
Exactly.
Like ultimate job protection. So but that's we're going to be the assholes that are going to make sense of it to everyone, and then they'll be like, ah. So all right, y'all. Okay, take care.
See you. See you, Travessia. See you, Monica. Bye, Noah.